Our strange lead is 390 light-years away, which is very far away. To be honest, 1 light-year is equal to 6 billion miles. Because people are always interested, we've come up with a weak explanation that goes beyond time itself. In an amazing turn of events, the amazing James Webb Space Telescope recently caught a charming look at a structure in the sky that existed before stars. This means that the object is older than the world itself. The effects of this shocking discovery are huge, and they have scholars desperately looking for answers to this puzzling puzzle. Could there be something wrong with how we understand the Big Bang? What forces helped make this strange shape, which dates back an amazing 13.8 billion years? We need to look into the details all over the huge, unending space. The James Webb Space Telescope has become an amazing spacecraft that views stars and the universe from a huge distance and sends its amazing views back to Earth. Recently, it showed an amazing sight, a divine structure that is 13.8 billion years old and tests the very basics of our knowledge of the universe. By looking at this amazing piece of machinery, we can see a big cosmic secret that is unexpectedly woven into the very fabric of space. This shocking discovery has led to many discussions and clarifications in the scientific world. Researchers and sites all over the world, including some of the most prestigious ones, are constantly being asked about this. One of the most common questions is how the James Webb Telescope can find a structure that is 13.8 billion years old when the world is much younger than that. To find out, let's start this trip with open minds, a lot of interest, and a sense of wonder that goes beyond what we normally experience. Before you can understand this strange structure, you must first look at it in the farthest reaches of the world. A well-known star called HD 14283 lives about 200 light-years away. This subgiant star, which is in the sign Libra and about 13.8 billion light-years from Earth, gives us interesting glimpses into its rough past. This star, which formed about 16 billion years ago, is not only unique because of its shape and properties, but it is also a strange case of time. Think about when the Milky Way was just starting out and it was taking in a small universe that used to be its home. But what really interests us about HD 14283 as a cosmic object is not just how quickly it works, but also how old it is compared to other divine elements we have seen. The lovely name Methuselah star comes from the fact that it is likely the oldest star we have ever seen. The age of this star has amazed astronomers, just like the biblical person Methuselah, who lived for a very long time. The first figures put its age at an amazing 16 billion years, but the most recent calculations using NASA's Hubble Space Telescope show that it is only 14.46 billion years old, with a margin of error of 0.8 billion years. Astronomers were shocked to learn how old it was, since the cosmic microwave background suggests that the universe is about 13.8 billion years old. This issue has brought up important questions about the age of the star, the age of the world, and, surprisingly, how accurate our dating methods are. People have done amazing things with their creativity to make the James Webb Space Telescope, which will change the way we explore space. This superpowered telescope, named for James E. Webb, a key figure in the early days of NASA, is changing the way we think about space in ways that have never been seen before. Its job is to find infrared light, and it can pick up signs from the universe's oldest and farthest objects, giving us a very clear picture of how the universe began. Now, before we get into the interesting details of how the James Webb Telescope found the 13.8 billion-year-old structure, let's make sure we all agree on how the age of the universe and other celestial objects is found. It can be hard to figure out how old things in space are. Take stars as an example. They are a lot like timeless light in that their brightness, temperature, and size haven't changed in billions of years, which makes them hard to date. Cosmologists use changes in a star's light and color to figure out how old it is by comparing what they see to models that show how stars change over time. One way to tell how old a star is by how fast it rotates, which is like how friction makes a wheel slow down. As stars age, they slow down too. What does the Milky Way show about how old this beaming image is? As we continue our search for cosmic knowledge, let us now turn our attention to the beautiful dance that is happening in our huge garden. Scientists have learned more about the Milky Way and found a beautiful display. Stars on the edges of our universe move more slowly and aimlessly than their partners in other galaxies. Since this discovery, scientists have been looking into the universe and are thinking that our Milky Way might be missing something important called dark matter. Dark matter is a mysterious substance that can't be directly identified. It pulls things in space together, playing a mysterious role in the cosmic dance. It's a huge puzzle that makes us think about what we know. Dark matter might not be what we thought it was from the viewpoint we use. Here comes the Gaia satellite, an artist in space from the European Space Agency who is taking the stage in the universe to show how complicated the almost 2 billion stars in our Milky Way are. Gaia is like a teacher for cosmic movement. She gives cosmologists exact measures that make them rethink their cosmic dance notes. The stars seem to move more slowly at the edges of our Milky Way, which makes us question what we thought they were moving at. The speed of stars can give us interesting clues about the mass of a galaxy, kind of like how we can figure out how big a group is by watching how fast people move. Based on Gaia's detailed data, cosmologists think that the mass of our galaxy's gas, dust, stars, and the mysterious dark matter is about 200 billion times that of our own Milky Way. Gaia's careful data shows that it now looks about many times less than what was first thought, which challenges our ideas about how common dark matter is. This new information leads to the idea that our cosmic soup might have fewer additives than we thought. But trying to gauge a galaxy is like trying to nail jelly to a wall, which is known for being very hard to do. Gaia's data could be wrong, or our cosmic measuring stick could need to be adjusted. Still, many research groups have joined the study of the stars, and they are all singing the same cosmic tune. If this cosmic discovery turns out to be true, it will open up a new chapter in our textbook on cosmic physics. It will also force us to look at our Milky Way and every other sparkling part of the universe with fresh eyes. We need to take a huge trip back to the 1970s in order to fully understand what this news means. Vera Rubin, an astronomer, and her team of stars set out to explain the patterns that stars in other galaxies make when they move. Astronomers used to think that stars on the edges of a galaxy would move more slowly than stars closer to the center of the galaxy. This is similar to how Neptune slowly circles the Sun, while Mercury moves very quickly and dangerously. During their research, Rubin and her team found something that truly shocked them. Stars far away in galaxies were dancing almost as fast as stars closer to the dance floor. This scientific find hinted at the existence of dark matter, a strange and hidden substance. Huge halos surround galaxies around the invisible heavyweight winner. Now, let's look at the Milky Way, which is our cosmic garden. You could imagine how creepy it would be to try to keep track of everything in your room while you were there. Astronomers had a similar problem because they thought that stars in the Milky Way followed the same rules as stars in other galaxies. Our Sun, which is about 26,600 light-years from the center of the universe, goes around at an amazing 800,000 kilometers per hour. The Gaia satellite was launched in 2013. It is like an accurate cosmic ruler because it carefully measures in 3 dimensions where the stars are in our Milky Way and how they move. The information it sent us back looks like the sound of a cosmic orchestra getting better over time. A few years ago, hypothetical physicist Francesco S. L. Solonius and his smart cosmic detectives from the Enrico Fermi Research Center in Italy picked up on small signs that the speed of spacetime was slowing down. When Gaia's most recent data drop happened in 2022, these hints turned into huge discoveries. The new information is twice as accurate as the previous estimates from 2018. This means that space scientists can use better tools to find the paths of stars with laser accuracy, even when they are very far away in space. 4 separate study papers published in 2023 have revealed a major surprise in the universe. Stars up to 100,000 light-years from the center of the Milky Way appear to be slowing down. It looks like the stars have decided to stir things up by dancing in a way that reminds us of the planetary ballet that Johannes Kepler wrote about many years ago. On the other hand, stars in other galaxies tend to move in a similar pattern, going from the center to the edges of their home galaxy without slowing down. This new information has led to a huge number of theories and opinions. One interesting option is that what we think we know about dark matter might need to be changed. Dark matter is a type of matter that only exists in theory. It doesn't interact with light or other electromagnetic waves, so it can't be directly found or detected. Its presence can be guessed from the way its gravity affects things that can be seen. According to the most popular theory, dark matter creates a thick, massless cloud around galaxies that adds to their gravitational pull and explains how stars and galaxies move. On the other hand, if the stars in the fact that the Milky Way is moving surprisingly slowly could mean that dark matter is not distributed or densely as was thought before. Researchers are now talking about other possible answers and new ways to look into this topic. One theory is that the different speeds of the stars could be caused by differences in how ordinary matter, like gas and dust, is spread out in the Milky Way. There is a chance that the visible matter's gravitational pull is bigger than thought, which would change how the stars move. Another interesting thought is that the very nature of dark matter might need to be rethought. Maybe we don't fully understand dark matter, and it acts differently in our world than in others. This could mean that we can look into different theories of gravity and the basic nature of the world in more ways. Like any scientific discovery, more observations, studies, and theoretical advances are needed to get to the bottom of this fascinating event. Cosmologists will keep looking at Gaia's data to improve their models and find new ways to ask questions. We are faced with an interesting puzzle because of the Milky Way's dance through space. It makes us think about dark matter and how galaxies move. It reminds us that the universe is a big, mysterious playground that wants us to start an astronomical journey of study and discovery that will never end. The desire to learn more about the world and the natural mysteries that keep challenging our ideas have always driven people to try to understand it. New developments in cosmic technology and methods have opened up new ways to look into the universe and given us insights that we thought were far away before. With its unmatched sensitivity and advanced imaging features, the James Webb Space Telescope is a huge step forward in our quest to see the farthest and earliest events in space. By looking at the light from old cosmic structures, scientists can see into the universe's early days and maybe find out things about how it formed and changed over time that were previously unknown. One of these discoveries is the cosmic microwave background, CMB, which is radiation from the very beginning of the universe that has taught us a lot about how things were at that time. Cosmologists have used the CMB's uniformity and small changes to help them make models of how the universe has changed over time. But problems with these models and recent findings, like the James Webb Telescope's identification of ancient structures, suggest that we might need to change what we think we know. This has made people rethink some important cosmological ideas, like how fast the universe is expanding and what dark energy is. Dark energy is thought to be what is speeding up the expansion of the universe. Also, improvements in simulations have let cosmologists make models of galaxy formation and motion that are more and more thorough. When we compare these models to data from telescopes like the James Webb, it helps us get a better idea of how galaxies change and interact. For example, simulations have helped us understand the role of supermassive black holes in the formation of galaxies. This suggests that their growth and development may be more closely connected to the universe around them than we thought. The study of exoplanets has also changed a lot because of these technical advances. The infrared sensors on the Webb telescope can look through the atmospheres of faraway worlds to see if they might be habitable or even home to life. This is very important for our search for life beyond our solar system and for our knowledge of other planet systems. We are always improving our ways of finding things and analyzing them as we continue to explore these faraway worlds. We want to find answers to important questions about life and our place in the universe.